And I'm not sure all of you are familiar with these topics, BNCT, but it's kind of one of the important methodology or cancer treatment. And BNCT is that the treatment which uses the neutron and boron 10. And as you know, the boron is the ultra trace element on the Earth, and B10, and B10 is the ratio of natural abundance of B10 and B11 is about 20 to 80%, 80%. And if the B10 is irradiated with thermal neutron, B10 decomposes into the two particles, helium particles and lithium-7. And because the special ranges of these two particles are about 10 micrometer, it is adequate to decompose the cancer cells around these two particles, because the size of the normal cells and cancer cells are very close to about 10 micrometer. Therefore, if you can accumulate the boron 10 compound in cancer cells, and irradiation of irradiation of the B10 compound with the thermal neutron, you can decompose or give a serious damage only to the cancer cells. And once again, the boron 10 consists of 5 nucleus, 5 neutron, and the irradiation of B10 with thermal neutron gives the introduce the decomposition of boron 10 into the helium, the lithium and helium, and this high energy. And once again, if you can accumulate boron 10 compound into the cancer cells, you can destroy only the cancer cells by irradiation with thermal neutron. So far, to be honest, many people have tried to design and synthesize many boron 10 compounds for BNCT treatment, BNCT purposes. But right now, only 2 compounds have been approved as the clinically compound, which are boronophenylalanine, which is abbreviated as BPA, and mercaptoborate, which is abbreviated as BSH. As I told you, many people tried the BNCT agents, which has many different scaffolds, such as porphyrins, nucleosides, amino acids, and carbohydrates. But once again, the only 2 compounds, BSH and BPA, have been approved as the BNCT agent. This slide shows our BNCT compound, which we have reported in these several years. First, we design synthesize the glucose compound having the carbonyl part on this side chain. And second, we introduced boron unit on glucose at the 2 position of glucose for as the glucose derivatives. And third category was the macrocyclic polyamine-based BNCT compound, which has B unit, boron ester unit on the benzyl group. And today I will talk about the result of the intracellular uptake and the toxicity and BNCT effect of these macrocyclic polyamine-based BNCT agents. Before that, I will describe about some result of the synthesis of the boron sugars. And we started the synthesis of this compound, boryl-2-glucose, from the glucar derivatives. And we carried out the hydrolyzation of this compound with boron agent to obtain the glucose compound having 2 boron unit. After that, this intermediate, normally this compound is used as the hydrolyzation, the substitution with hydroxide to give the alcohol. This is the typical and traditional methodology to obtain alcohol from alkene. But in this work, we have decided to treat this compound with diol to obtain a cyclic ester group at the boron compound, which is very stable even in aqueous solution. Synthesis of this compound was carried out like this one. Actually, glycol was hydroxyribonucleic glycol was protected to a acyl group, and after hydrolyzation, we got this compound, which structure was confirmed by extracellular analysis as shown here. After that, the TBDM group, protecting group, was removed by trifluoroacetic acid to obtain this type compound. And we have synthesized several very compounds, glucose derivatives, and carried out the measured the intercellular uptake of these compounds under normoxia, hypoxia conditions into the HeLa cells and A549 cells. As you can see here, the very compound, very glucose 17, 9, 11, and 16 was uptaken into cancer cells, but even better or very close, that the intercellular uptake of this compound almost same as the BP and BSH, as you can see here, even under the normoxia and hypoxia conditions, and after the infusion for 24 hours. And we found that this compound, MK1, which was used as the control compound, was introduced to cancer cells, HeLa cells, and A549 better, higher than these glucose derivatives. What is this macrocyclic compound? We should introduce about the molecular recognition of gene complex, the 12-membered cyclic, 12-membered cyclic tetraamine, which we call cyclin. A zinc cyclin complex is very stable even in other aqueous solutions at neutral pH, and it has been well established that zinc cyclin complex recognize the thymidine, the protein thymidine, to form 1-to-1 complex by the coordination bond between imidine ion and zinc, and the 2 hydrogen bondings between carbonyl oxygen and amino protons. This coordination proceeds by the deprotonation of thymidine, which is one of the nucleoside in DNA. And KD value is not so significant, but it was the first compound that recognized the thymidine in aqueous solution and to neutral pH. And we have assumed our hypothesis was that if you can introduce boron 10 into the zinc cyclin complex, this compound should recognize the thymidine in DNA double helix, and to put this compound, this boron 10, close position to the DNA. And upon some addition with some neutron, boron 10 will be decomposed to helium and lithium, which should give a serious damages to the DNA. That was our next hypothesis. Based on the hypothesis, we synthesized the many macrocyclic polyamine compounds having the boron ester units. We carried out the synthesis of this compound from 9-member ring and 12-member ring and 50-member ring macrocyclic compound, and I introduced this borono benzoyl group to give this compound, and boron ester unit was protected with this bi-cyclic 1-1 diols to obtain hydrophobic compound. After that, the bulk group was protected, and finally, zinc. This compound was zinc complex was prepared in situ in water or with the zinc nitrate. The middle compound was also prepared, as you can see here, and the structure of this zinc complex was confirmed by X-ray structure analysis, as you can see here, for HU21. The intercellular uptake of this compound was measured, as you can see here, and intercellular uptake of K1 is higher than previous compound besides BPS, as I told you before. And this compound, HU 27, 20, 32, 28, 22, 33 was the intercellular uptake of this compound was higher than, especially into the A549 cells, or higher than MK1 compound. And I should say the zinc complex of this compound was uptaken lower uptake of zinc complex, because this zinc complex was observed, as you can see here. At the same time, cytotoxicity of boron compound was measured, and this is the activity value of these compounds, and it was found that these compounds are normally less toxic than MK1 and other some compounds, suggesting that these compounds are safe, not less toxic compounds. This graph shows the boron uptake. The x-axis is boron uptake in killer cells, and the y-axis is the selectivity against the tumor cells and normal cells. Therefore, the upper right points suggest that these are the compound is the compound is uptaken in cancer cells more efficiently and with the highest tumor cell normal cells selectivity. This one shows the graph for the HeLa cells and IMR90 cells, which was used as a normal cells, model of the normal cells. And from these graphs, we have selected 3 compounds, Hu22, 28, and 32 constellation with these toxicities. Therefore, so far, the boron compound was synthesized as the cold compound, including boron 10 and boron 11 in the natural abundance ratio. But after the determination of after selection of these 3 compounds, we have synthesized the corresponding B10 enriched compounds, B10 Hu28, B10 Hu22, and B10 Hu32, and the corresponding gene complexes. After that, we carry out BNCT experiments using A549 cells at the Institute for Integrated Radiation, Nuclear Science, Kyoto University. Namely, the cells, A549 cells, were incubated to which these 10 boron 10 compound was added and incubated for 20 hours. The summer neutron was irradiated. And after that, cloning assay was carried out for the evaluation of BNCT effect of these 10 boron 10 compounds. This picture shows the result of the cloning assay of the cancer cells after irradiation with summer neutron for 12 minutes, 50 minutes, 30 minutes, 45 minutes. This one is the control, and the BSH and BPA shows that the gradual decrease in colony of the cancer cells. And you can see in these red boxes, we have found that B10 enriched Hu28, 22, and 32 induce the considerable anti-cancer activity after irradiation with summer neutron. After that, we carried out some mechanical studies about the intracellular uptake of this compound, especially Hu32 for comparison with the BPA using the inhibitor of these events. Methylcyclodextrin, beta-cyclodextrin, which is the inhibitor was Carbora endocytosis inhibitors, Dinosaur, the classic endocytosis inhibitor, amylolide, the inhibitor of micropinocytosis, and spermidine, which is the substrate of polyamine transporters. As suggested by these red arrows, this inhibitor of sclerostin endocytosis and polyamine compound, which is a competitor of the polyamine transporter, induces the intracellular uptake of Hu32, this compound. Therefore, it was suggested that this compound is transported into the cancer cells by polyamine transporter and endocytosis based on clustering. And this slide compares the intracellular uptake and BNCT effect of 9-membrane 12-member ring and 15-member ring compound, which has boron unit. As you can see, the intercellular uptake of boron 9-member ring, Hu28, has higher intercellular uptake than those of 12-member ring and 15-member ring. However, this graph shows indicates the effect of this compound on BNCT, showing the surviving fluctuation from the original number 1 to 0.1, 0.01, 0.001. And this graph shows B10HU45 gene complex as highest BNCT effect among rather than the B10HU28. On the other hand, HU22, B10 enriched compound of HU22 and HU32 has even higher BNCT effect than nine-member ring. Also, the intercellular uptake of 12-member ring, 15-member ring are lower than that of 9-member ring compounds. From this result, we assume that the mechanistic aspect of the BNCT effect of 9-member ring and 12-member ring, HU22 and 32 compounds, HU32, which is 15-member cyclic compounds. It is assumed that these compounds are transported to the into the cancer cells by the endocytosis or by the polyamine transporters. These cation compounds would interact with anionic DNA, result in the efficient breaks of DNA upon the summary neutron irradiation. At the same time, we assume that these compounds form gene complexes for the recognition of thymidine in DNA, which also induce the serious DNA damage upon the irradiation with thermal neutron. Therefore, we think that these compounds, metal-free compound, gene complex, both of metal-free complex, gene complex of these ligands interact with the DNA in nucleus of the cancer cells with efficient breaks of DNA upon the irradiation with thermal neutron. This is the summary of our result. We think that these compounds, gene complex and corresponding metal-free ligand, interact with DNA due to the coordination bonds or electrostatic interactions for the efficient breakdown of DNA upon irradiation with thermal neutron and resulting in cell death in cancer cells. As I told you that gene complex recognize thymidine, one thymidine with these KD values. At the same time, later we reported that this gene complex, which has two gene complex parts with two thymidine, which has two thymidine parts, forms the one-to-one complex with lower KD values. I mean, this complex is much stable than monomeric gene complex, thymidine complex. Therefore, we carried out the synthesis of dimeric gene complexes, homomeric and heteroreptic gene complexes having B10 unit. As you can see here, we started the synthesis from this dibromide at 1 unit of monocyclic polyamine. Macrocyclic polyamine was introduced. After that, the second polyamine compound was installed at this group to form the heteroreptic and homoreptic ligand compounds. After the protection of both groups and the pre-metal ligand was reacted with the this diol to obtain this compound, which was converted to the gene complex in situ. The intercellular uptake of the dimeric gene complex was measured, but unfortunately, the intercellular uptake of these compounds were much lower than monomeric gene complex, monomeric boron compound. Besides BNCT effect of these dimeric metal-free dimers on the metal gene complex of the dimers were much weaker than monomeric compounds, unfortunately. So far, we carried out the synthesis of the BNCT variation of 24 monomeric type macrocyclic polyamines boron compound and 26 types of homeric homo and heteroleptic dimer types compounds. And we carried out the synthesis of the boron 10 enriched compounds and found that this monomeric compound has the highest BNCT effect among these about 15 macrocyclic compounds having the boron unit. Recently, we carried out the effect of this compound of the tumor cancer-bearing mouse models and found that this compound, boron 10 enriched Hg22832, is not so toxic against the cancer-bearing mouse models. And this compound is accumulated liver and cancer sites. And the BNCT effect of our compound B10 enriched Hg222 was carried out and found that the tumor growth in the presence of this compound upon irradiation with thermal neutron induce the suppresses the growth of the tumor cells. Body weight was not so affected by this compound, once again, suggesting that these compounds are not so toxic against cancer-bearing mouse models. Finally, some of these results were introduced, published in Journal of Medicinal Chemistry last years. If you are interested in this work, please refer to these papers and reviews. This is my last slides, in which I will show you the pictures of our research group. I am very proud of working with these excellent and capable student staffs. And I appreciate the financial support from these Japanese government and private foundations in Japan. And thank you for your attention. Thank you so much.